Battery electric trucks are the most concrete and effective solution for decarbonizing transport in the coming years. Batteries lie at the core of this new technology. Invented by Alessandro Volta in 1800, they have evolved throughout the ages. The first lithium-ion battery was developed in 1985, although they were not commercialized until 1991. The advantage of lithium over copper, platinum and nickel? It allows more energy to be stored with less space and weight, while offering a longer life for the battery. Let's take a look at where we are today through 6 questions. What are the components of a truck battery and how does it work? What's the production process and how do the minerals used impact the environment? What is the truck battery range? What is the duration of a truck battery and what is its complete life cycle? What future developments can we expect in terms of battery technology and price? And lastly, the question everyone is asking, when's the right time to switch to electric? Let's first look at the components of batteries and how they work. At the heart of the battery are the cells. Cells consist of an anode, cathode, electrolyte liquid and separator. When the Li+ ions migrate from the anode to the cathode and back again, they supply electricity and recharge the battery. The cells are assembled by 12 to form a module, and 30 modules together, with sensors and control units, make up a pack. A thermal regulation system keeps the cells at a temperature of 15 to 35 degrees Celsius. Protective packaging ensures the insulation and safety of the battery. Here is what a pack looks like in a Renault Truck D-Wide E-Tech vehicle. There are 3 to 6 packs per truck depending on the desired range. The safe use of batteries is of course of paramount importance. This is ensured firstly by a carefully thought out design and secondly by validation tests that meet precise standards. Then, when the electric vehicles are delivered, the instructions for use are clearly explained to the users. Last but not least, in the maintenance and repair networks, labels have been introduced to ensure that garages have the right levels of equipment and qualifications. Let's now look at the production process of batteries and the environmental impact of the minerals used. The entire production process ranges from extraction of the minerals used to make the electrodes to assembly of the packs. The minerals used are mainly lithium, nickel, cobalt and manganese. These are not scarce resources, and according to a 2021 report by the International Energy Agency, the reserves of these minerals are sufficient for them to be used today on a large scale in the production of batteries. The mining industry is investing heavily to accommodate the rise of electric cars and trucks. Manufacturers are very careful about how these various minerals are extracted and processed. They do this in 2 main ways: through a supplier code of conduct for the responsible sourcing of raw materials, through the introduction of labels and the related traceability. It is about ensuring that environmental conditions, soil protection, biodiversity, water and waste management, and societal conditions, health, safety, labor rights, human rights, are met throughout the production chain. The manufacture of cells currently account for 70% of the battery's carbon footprint. The relocation of cell manufacturing to Europe should reduce the carbon footprint of the battery by using less carbon-intensive electricity. This footprint is expected to almost halve over the next 15 years to an average of 50 kilograms of CO2 per kilowatt hour. Finally, although Europe is already self-sufficient in terms of battery production, 22 gigafactories are scheduled for construction by 2025 to absorb the increase in requirements. Battery range is another subject that raises a lot of questions today. It is difficult to give an order of magnitude because many parameters influence range, such as how the truck is used, its load and equipment, outside temperature, and the topography of the terrain. This is why we are increasingly expressing range in terms of usable energy. I'll give you a simple example of the calculation. In order to preserve the battery's lifespan, it's important to avoid discharging it beyond 10% and charging it beyond 90%. At the beginning of battery life, it's therefore considered that the maximum usable energy is 80% of its nominal capacity. A 16-ton truck used for urban distribution with the dry body will consume on average 0.9 kilowatt-hour per kilometer. If it's fitted with 4 66 kilowatt-hour battery packs, providing a total of 264 kilowatt-hour, we can determine its theoretical range at the beginning of its battery life. To do this, we take 80% of the nominal battery capacity and divide it by the average consumption per kilometer. In this example, this gives us 230 kilometers. Theoretical calculations aside, it's important to keep two elements in mind. The first is that when you brake, the battery recharges. This means you can regain autonomy while driving. The second is that before the purchase of a truck, a detailed analysis of the company's activities and facilities is carried out to define the vehicle and charging infrastructure that are suitable for the daily tasks involved. As the proposed transport solution matches the requirements, range is no longer a concern. Do you know how long a truck battery lasts and what its life cycle is? Batteries age due to mechanical stress and alteration of the electrolysis process. The capacity and power of the battery decreases in a nonlinear manner with time and use. The health of a battery is defined by this indicator. A battery is deemed to have reached the end of its first life on a truck when the maximum usable energy is only around 80% of its initial capacity. The duration of this first use is estimated at between 6 and 10 years, depending on use. What happens after this? The good news is that a circular approach to battery is emerging. This will limit the need for natural resources in the near future. There are 3 possible steps. Firstly, batteries can be reconditioned, in other words, refurbished by replacing all the modules. They will then be as efficient as new batteries and used as spare parts for standard exchange on trucks. Even when used, batteries and modules still have considerable capacity. They can then be used in the second life for stationary energy storage purposes, for example, in housing, for up to 10 additional years. Finally, when they're no longer efficient enough and no longer usable, batteries are sent for recycling with the aim of re-injecting the recycled materials into the production of new batteries. Europe is drafting a new law under which manufacturers will be responsible for tracing, collecting, and recycling at least 70% of the battery's weight by 2030 and for using these recycled materials in their battery production. What future developments can we expect in terms of battery technology and price? By the end of the decade, the proportion of solid-state lithium-ion batteries will increase, with higher energy densities than current batteries. This will allow, either at constant usable energy on the battery, a reduction in weight and thus free up payload, or at constant battery weight, an increase in the usable energy of the battery. To give an order of magnitude, it's estimated that by 2030, weight will be reduced by between 500 kilograms and almost 1 ton per truck, depending on the number of battery packs installed. Now for the price. On the one hand, we have the price of raw minerals. This currently represents about 1/5 of the cost of the battery pack. Initially, the high demand is likely to generate high volatility in mineral prices. Then, mining capacity will increase over the next 5 to 8 years, and prices will stabilize. On the other hand, economies of scale will be made in the manufacture of cells and packs. It is estimated that these economies of scale will cover the volatility of mineral prices. Ultimately, this should lead to a significant reduction in the cost of battery packs. To sum up, technology will continue to evolve. Batteries will weigh less, have more available energy, and their price will drop. For this reason, it is difficult to identify the right time to invest. Decarbonization of transport is a major and collective challenge. Starting to invest today means contributing to this societal challenge. It also allows us to test, learn, and prepare for a complete energy transition. The world is changing, society is evolving, and so are mentalities and public opinion. In conclusion, here's a list of the key points we've covered. Batteries are housed in packs, and there are 3 to 6 packs on a truck. It's the correct sizing of the number of packs and the charging infrastructure that will ensure the smooth daily use of battery electric trucks. Minerals are used to make the electrodes in batteries. They are not rare resources, and manufacturers are very vigilant with respect to extraction methods. The carbon footprint of battery production is expected to decrease over the coming years, particularly with the development of gigafactories in Europe, which will use an increasing proportion of decarbonized electricity. The first life of a battery lasts from 6 to 10 years, depending on usage. It can then be reconditioned as a spare part, reused for energy storage, and finally recycled. Technological developments will improve the weight and performance of batteries. Their price will come down. Lastly, investing in battery electric vehicles today gives the means to understand the ongoing energy transition, improves brand image, and contributes to the climate challenge. So, I hope you now have a better understanding of the core component of electric vehicles, the battery.